Hey guys, here is our video for chapter 3.1, which is a unit about quadratic functions. Remember, quadratic means I have a function where the degree is 2, that it's squared up here. So there's a lot of ways to solve quadratic equations. Some of them work in certain circumstances and some of them do not. The easiest one by far is solving by square roots. The thing is, the square root function doesn't work all the time because see how there's no x term in between. Like, in a diamond problem, there's an x term. Well, it doesn't work when there's an x term. So when there's not an x term, when there's something like this, and I can isolate the perfect squared term by moving everything else to the other side, then I'm able to use square roots. So what I want to do, guys, is I want to isolate the squared term. Now notice that all the instructions are on your notes, but I don't have room on the small board to write it. But what I'm going to do is I'm going to isolate this x squared. I want to isolate that. So that means I'm going to first add the 31, and I'm going to get 4x squared equals 80. Right? Now it's tempting to say, oh, the x squared is isolated, but it's not because the 4 is there. So I have to divide by the 4, and I get x squared equals 20. Okay, I have to get x, not x squared. So that means I need to undo the x squared by doing the inverse operation. And the inverse of a squared is a square root. And of course, I'm going to square root both sides of the equation. So when I square root x squared, I get x. And then I have to make sure when I square root the other side that I have both the positive and the negative root. There are two solutions. Now, square root of 20 is not a perfect square. So what I need to do is I need to simplify the square root of 20. So if I notice, I can do it one of two ways. I can either make a factor tree, which is probably what you learned before. I can say that's 5 times 4, right? 5 is prime. And then I can say it's 2 times 2, right? And if I take out a pair of 2's, it becomes a single 2 on the outside, and the 5 is alone on the inside. So here I get x is plus or minus 2 square root 5. Okay, again, no x term in between, in the middle, so I can actually use square roots here. Again, I'm going to isolate the squared term. So I'm going to subtract the 9. 3x squared equals negative 9. Then I'm going to divide by the 3. And I get x squared equals negative 3. I don't know if any of you have noticed a problem yet, but when I go to square root, I've got a problem here, right? I can square root x, x squared, but I can't square root a negative. Not in the world of real numbers, at least. So I'm just going to have to say no real solution, right? Because I can't have a negative under square root. Right? I can't have a negative under the square root in the world of real numbers. So that's why I'm just going to say no real solution. Okay, guys, there's one more of these. Unfortunately, I only have my one single board today. Here's the third one. Okay, here's our third one. Now, this one's definitely the trickiest. First, the tricky thing is the squared term is not as easy to spot here. Because you see, guys, it's not the x that's the squared term. It's the entire x plus 3 that's the squared term. So what I want to do is I want to isolate the x plus 3 squared. So that means I got to move the 2/5 over here. So I could divide by 2/5, which is fine, right? If I do 5 divided by 2/5, that's the same thing as 5 times 5 over 2. So that is 25 over 2. So what I've got now is x plus 3 squared equals 25 over 2. Okay guys, so I've now isolated the square term, so what I have to do is square root both sides. And by that, I'm going to square root everything. And if I square root x plus 3 squared, I'm left with x plus 3. And remember the plus or minus here. The square root of 25 is 5. And the square root of 2, that is not a perfect square. Now, I don't remember if you remember from geometry, I'm not allowed to leave a radical on the other side of the equation like that. So what I have to do is I have to multiply the top by square root of 2 and the bottom by square root of 2. And the reason I do that is that when I take the square root of 2 and multiply by itself, it's just equal to plain old 2. And then up here I multiply 5 times root 2 and get 5 root 2. So here's where I'm at right now. I'm at x plus 3 equals plus or minus 5 root 2 over 2. And my goal is to get x by itself. So I'm going to subtract the 3, and I've got x equals, now I can't combine a negative 3 with something with a root. So I have to leave it as negative 3 plus or minus 5 root 2 over 2. And there are my solutions for solving with square roots. So you may be wondering at this point, well, Miss Brindley, what does it look like when you can't solve using square roots? Like, when is that method not available to you? That's our next step. Okay, so next, we are going to look at solving quadratics by factoring. Okay, so suppose I have something like this. Now, is it possible to isolate the square term there? Well, not without having other x's around, right? So I could get x squared by itself, but then there's going to be an x on this side of the equation. So square roots aren't available to me in this situation. So what I want to do here is get 0 on one side, right? And I can do that by subtracting 45. So I've got x squared minus 4x minus 45 equals 0. So what you want to do is you want to look for patterns. The type of factoring you're going to do in this situation is called trinomial factoring, or we kind of nickname it diamond factoring. So we want to make ourselves a diamond, and in the top we are going to put the a value, which is in front, times the c value at the end. And we're going to say, we're going to do 1 times negative 45, and that's going to go up here. And here we're going to just take this middle term, which we call b. I'm going to put it there. And I'm going to ask, what are two numbers that multiply to the top value, which is negative 45, and add to the bottom value? What are two numbers that multiply to negative 45 and add to negative 4? Well, perhaps you've noticed already, negative 9 and 5. Okay, so what can I do at this point? Well, I've now taken this negative 4 and split it into negative 9 and 5. So that's what I'm going to write up here. I'm going to say x squared, but instead of writing negative 4x, I'm going to write minus 9x plus 5x minus 45. Okay, so what I want to do at this point, notice that's still equal to x squared minus 4x minus 45. It's just I've split that negative 4 in the middle. So what I'm going to do is I'm going to put a bracket around the first two terms and a bracket around the second two terms. And in each one, I'm going to look for a greatest common factor. That means something that both of these share. And do you see how they both have an x? Now this one has x squared, this one just has x. I can only take what's in common out. So if I factor an x out of x squared, I still have an x. And then here, I just have a 9. Okay, second group, I'm looking for the greatest common factor. and I notice that 5 is the greatest common factor. And if I factor out a 5, I'm left with x minus, and then 5 times 45 is 9. I'm hoping you guys notice at this point something kind of interesting. The two parentheses expressions are the same. So that means that we did our diamond right? So what I'm going to do at this point is I have two terms right here, two sets of greatest common factor problems, and I notice that x minus 9 is familiar, is common to them. So I'm going to factor out the x minus 9, and then I'll be left with x plus 5. And remember, that's all equal to 0. So why do we do that other than the sheer fun of it? Well, we know here that if x minus 5 times x plus 5 equals 0, that means if I can find an x that makes x minus 9 0, or in other words, let's write a little equation, figure out how I can make x minus 9 0, that means the whole thing would be 0. And the same thing with x plus 5. If I take x plus 5 and try to figure out what x value makes it 0, my whole expression will be 0. So now we just have to solve, and we get x equals 9 and x equals negative 5. So those are our two solutions to that problem. Okay, guys, so we're going to do one more of these just so you can get in the groove of doing some factoring, because this is a very important skill to have. Okay, here's problem B. All right, now getting one side to be 0 is going to be a little bit more of a drag on this one. Okay? Okay, so when I do diamond factoring, I actually like to have the squared term have a positive number in front of it. So what I'm going to do to get one side equal to 0, I'm actually going to move, even though it takes a little bit more work, I'm going to move the numbers over to the right side. So what do I have? I have 2x squared plus 5x minus 12. Okay? So I want to do, so this pattern, if you guys notice this pattern, I have something x squared plus something x and then a number at the end. That is diamond factoring. So let's set up our diamond. We want two numbers that multiply to the first term times the last term. So 2 times negative 12, which is negative 24, and add to that middle term, which is 5. Okay, guys? Two terms that multiply to negative 24 and add to 5 are 8 and negative 3. So what I'm going to do is I'm now going to take the quadratic, which is 2x squared plus 5x minus 12, and rewrite it as 2x squared plus 8x minus 3x minus 12. Still the same value, I'm just splitting that 5x. Then I'm going to put brackets around the first two and brackets around the second two. And notice, guys, there's a minus here. So that's going to make it a little bit trickier. Okay, greatest common factor in the first group. Well, there's a 2 for sure, because 2 and 8 both share a 2. And there's also an x. If I factor out a 2x from 2x squared, I'm just left with x. And if I factor a 2x out of 8x, I'm left with plus 4. Now notice here when I factor out a greatest common factor, I'm actually factoring out the negative value of that greatest common factor. So if you guys notice that 3 is the greatest common factor, but what I've really factored out is negative 3. So if I factor out a 3 from here, I get x. And if I here notice, because I factored a negative 3 out, it actually becomes x plus 4. So again, these are the same, right? If those are the same, I can write it as x plus 4 times 2x minus 3. So I've got it all factored out there. And now I can set each one equal to 0. X plus 4 equals 0, and 2x minus 3 equals 0. So this one, x equals negative 4. And this, if I add 3, right, I get 2x equals 3, and x equals 3 over 2. So those are my two answers, 3 over 2 and negative 4. Okay, guys, there's one more thing that this chapter asks you to do, and it's kind of conceptual. It's basically the same as this, but it's conceptual. There's an additional step. So what they asked me to do is to find the zeros. Okay, so I've got this. F of x equals 3x squared plus x minus 2. Now you may wonder, the last problems we had an equation. We didn't have an f of x, right? Here it's saying find the zeros. Another word for zero is x-intercept. So if they're asking me to find the zeros, what they're actually asking me to find is the x-intercepts. And if you guys remember from those parabolas that we were graphing, to find an x-intercept, I make y equal to 0. Well, f of x is y. That is y. So I'm going to make that equal to 0. And what they want me to do is they want me to find the values of x that make it 0. So what I'm going to do is factor. So I'm hoping this pattern comes out at you. I've got an x squared, an x, and a number. That means I am going to do a diamond problem. Two numbers that multiply to 3 times negative 2, which is negative 6. And then there's a 1 in front of here, right, guys? And add to 1. Multiply to negative 6 and add to 1. Well, to me, that is 6 and negative 1. Right? So I'm now going to say I've got 3x squared plus 6x minus 1x minus 2 equals 0. Again, we're going to take brackets around the first two, brackets around the second two, and remember there's a minus there. What's our greatest common factor in the first group? Well, they both have a 3, because 3 goes into itself and 6, and they both have an x. So if I factor out 3x from 3x squared, I'm left with just x. And if I factor out 3x from 6x, I'm left with a 2. Okay, this one's weird. There is no greatest common factor. So when there's no greatest common factor, I put something there. I'm just going to put a 1 there. Right, don't just leave it blank. You want to put a 1 there. So if I factor out a negative 1 here, I'm going to be left with x. And then remember, guys, this is a minus, so that's going to become plus 2. So now what I've got is I've got x plus 2 times 3x minus 1. All right, let me make another little bit of room here. Okay, so if I've got x plus 2 times 3x minus 1, I can set each factor equal to 0. So I can say x plus 2 equals 0, and I can say 3x minus 1 equals 0. So again, that's going to get me 2 answers. The first one's going to be negative 2. And the second one, I'm going to add 1 and get 3x equals 1, and then divide by 3. So I get x equals 1/3. Those are the zeros. So I can say, if I say solve the quadratic, that also means find the zeros. But notice the step at the beginning, I had to make f of x equal to 0. And then it became exactly the same. Okay, guys, here's the grand finale. Or I thought there was a grand finale. Okay, guys, so the problem on the back says that there's somebody building a ramp. And the sides are in the ratio 5 to 12. The legs are in the ratio of 5 to 12. And we want to find x and the length of each side. So they're saying it's a triangle, a right triangle like this. And if you guys remember, we have this thing called the Pythagorean theorem, right? So I can say, if I say that's A and that's B and that's C, I can say it's A squared plus B squared equals C squared. Now, what they're saying though is that the legs, these two are called the legs and that's called the hypotenuse, are in the ratio of 5 to 12. So they're not saying they're equal to 5 and 12. They're saying the ratio is 5 to 12. So that means this leg is some multiple of 5, and this leg is some multiple of 12. So they want to solve. They want me to solve for x. Oh, and I can't remember the number on the other side of the. Oh, hold on, guys. I picked up the wrong set of notes. Okay. I'm just going to make this, this ramp here is going to be equal to 120 feet. I don't know if your example says 120 feet, but let's just say, actually no, we'll say it's, actually let me do the first part first. I'm sorry, I'm doing this, I don't actually have the problem in front of me. So this is our A, this is our B. So I'm going to say I have 5x quantity squared plus 12 quantity squared equals, and I'm going to fill in this number in a second. Well, if I square 5x, that's 5x times 5x. So that's 25x squared. And if I square 12x, that's 12x times 12x, which is 144x squared. So if I add those up, I get 169x squared. And I also don't have a calculator up here. You guys, you know what? I may just have to be scratching this example. Sorry. I thought my notes had that example on it, and they don't. So we're just going to scratch this example. So we're not going to get any quiz question on it or practice problem on it. So I apologize to all you advanced algebra students out there. If you want to continue the problem on your notes, you can do it. Otherwise, you can just exit out. Okay, guys, that's the lesson on square roots and factoring, and I will see you very soon.